Okay, lesson 14 here called app deployment. And to start lesson 14, I want to revisit the DevOps diagram that we've been referring back to. And right now we are in this region here, this release and deploy region in this diagram here. Of course, we've talked about the few steps prior to this. We talked about coding. That's most of what we've done this semester. We talked about building, and we talked about testing our software using unit tests and other types of testing. And now it's time to talk about releasing and deploying our software to our users, because that's what we built it for. That's who we built it for. So that's what today is all about. And this topic falls into the deployment engineer software development role. So sometimes deploying the software is a big enough task that there is a specific person or a specific set of people, and their job is to deploy the software, not to write the software, not to test the software, to deploy the software. So sometimes it's a big task, and sometimes sometimes there's one person that does all these things. Okay, so it's just another mindset that we kind of have to talk about when understanding the job functions of a software development team. Okay, so the mindset and the tool set of the deployment engineer is kind of interesting compared to what we've seen previously. In particular, you'll notice there's no C# on this diagram. So a deployment engineer doesn't care about C#, at least not in the same way that a software developer cares about C#, or a unit tester cares about C#, or a data analyst who's using C# to perform an analysis cares about C#. A deployment engineer does not care about C# in that way. They don't care about all those nice language features and fluent syntax and everything that we've been talking about. Instead, they care about things such as, well, where's the software going to go? Okay, right? Is this software going to be deployed on a desktop computer, a laptop computer? Is it going on a mobile device, a tablet? Is it going on a Xbox? Where is the software going? Is a primary thing that a deployment engineer needs to think about. And even though a deployment engineer might not care about particular coding details, they still care, where is the code located? The code is what makes the software. So they care about Git, they care about third-party libraries and NuGet, because our software is going to be dependent on those libraries. They care about, I guess the new thing here that they care about is Azure Pipelines. So we'll talk about using Azure Pipelines to automate the deployment process. And there's also a little tool in Visual Studio here that is kind of an easy way to deploy software in certain environments. So that's this Visual Studio Publish tool. So that could be an option depending on what kind of software is being deployed. Okay, so one thing we want to acknowledge when starting the discussion on app deployment is, in this course thus far, Visual Studio has been managing this whole thing for us. So with what we've discussed, the only way to run or execute our application is to install Visual Studio, clone the code in Visual Studio, and then click the run button in Visual Studio, and that's how we've been running our app. And so, this is the lesson 10 application here. And if we tell our user that that's how they need to run our app, install Visual Studio and so forth, then they're probably not going to be our user very long. We need to give them some easier way to use our app and kind of understand their needs during this software deployment process. So getting our software or our app to our users in a format that they can work with comes with a number of requirements, and I've split these requirements out into 3 different categories here. So technical requirements, delivery requirements, and business and organizational requirements. So we're going to talk about each of these groups of requirements and maybe touch on a few things that we might want to think about. Okay, so the technical requirements are the cold hard facts about what needs to be true about the user or the user's machine in order for them to use our software or to use our application. And so an example technical requirement might be the user needs a machine with the Windows operating system on it in order for them to use our application. Or if we made a mobile application that works on a phone, right? The requirement might be that the user needs a device with either the iOS or the Android operating system to use our application. Some other technical requirements might be the user needs a web browser of a certain version or later to use our application. So these are various technical requirements, and these are requirements of the user or the machine the user's using to use our app. And the requirement for a C# app now is the user must have to use our C# app. The user must have the .NET runtime installed on their machine. Okay, that's our main technical requirement. So we're going to talk a little bit about that. So earlier in the semester, I think when talking about third-party libraries, I think I said something along the lines of your C# code gets read in by a compiler, and the compiler compiles or transforms the code into binary or a series of ones and zeros, and the computer, the underlying computer, reads those ones and zeros or reads that binary, and that's how your app is executed. This is actually not true in the C# programming environment. There's some intermediate actors in between during this process, and so and that intermediate actor is, or one of them is the runtime, the .NET runtime, and so we're going to flesh out those details here just because this is our main technical requirement that we will require of a user in order to run a C# app. And so let's first talk about when this is true. So this is true in when you're programming in C and I think C++. When you're using these languages, you do give that your program to the compiler, and the compiler does produce the ones and zeros or produces the binary, and that binary is what's executed on the machine. But the challenge in this environment is that the compiler needs to know the machine's hardware architecture in order to produce the ones and zeros or the binary in the correct format. And so some various computer architectures might be the x86 architecture, or 64-bit architecture, or ARM is a new architecture. And these compilers need to know about that architecture to produce the binary, because the binary will look different on a x84 architecture versus a 64-bit, or an x86 architecture versus a 64-bit architecture. So these details are covered more thoroughly in a computer organization class or a computer architecture class, but just understand that this is something that your compiler needs to understand. And so this means the compiler for a C program on a 64-bit architecture is going to be different than the compiler on an x86 architecture. Okay, so there's that. And additionally, some programming tasks require knowledge of how the operating system needs to be interacted with. So the file system on a Windows machine is different than the file system on a Mac. And that can lead to some differences in how you program the communication between your program and the operating system it's hosted on. So this tends to be a little bit more complicated of an environment, and that is because there is no intermediate runtime. And so let's talk about the C# world, or the world where we have an intermediate language and an intermediate runtime. So how it works in C# is your C# code gets passed into the C# compiler. This is something that Visual Studio is doing for us. And that compiler, I think the main one is called Roslyn. And what it converts your C# code to is an intermediate language. And this intermediate language is not binary, but it's also not it's not a nice language like C#. It looks much more computery, I guess you could say. So the intermediate language in our environment is called the Common Intermediate Language, or CIL. And this is what is stored in your DLLs, for example, and this is what you ship to your user. You're shipping code that is stored in this intermediate language. And then what happens when the user goes to run a C# application is this intermediate language is passed through a just-in-time compiler, or the .NET Runtime is another thing you could generally call this. And the just-in-time compiler will compile instructions that are in the intermediate language into binary instructions that get executed on the computer's circuits or on the computer's hardware. So this is how it works in the C# environment, and it's also how it works in the Java environment. So we'll talk a little bit about that. But this is what that intermediate language looks like. So it's not so nice. This is not something a programmer would typically want to work with directly, at least not from my perspective. So this is it, and it's providing very low-level instructions about what needs to be executed step by step on the computer's circuit. So that's what this is for, and again, it doesn't look great, and you don't really want to work with this code directly. You want the C# compiler to produce this code for you. So let's talk a little bit more about why it might be helpful to use this intermediate language in this intermediate runtime in between our C# code and our binary code. So here's a similar diagram to the last one, but the first advantage is that C# is not the only programming language in the .NET environment, or it's not the only Microsoft programming language. There's also F# and there's also Visual Basic. These are different programming languages with perhaps different objectives, different history, and so on. So, but regardless of the language, whether it's C#, F#, or Visual Basic, the compiler can transform code in these languages all to the same intermediate language. And what that means for us is that we can write applications or programs or software that has components of it written in C#, has other components written in F#, has other components written in Visual Basic, for example, and that will all compile down to the same intermediate language, and each of those components can be used freely between each other, right? So, because it's all going to the same target language anyway. Okay, so that's one advantage. But the other advantage, and the original advantage of a runtime, is that if you don't do this, if you don't store your code in an intermediate language, then you have to know the machine that your user will be using. you'll have to know, is it 64-bit? Is it x86 architecture? Is it an ARM architecture? You have to know that detail. And so your options are to either know that exact fact or to compile your code using all the different combinations of operating systems and computer architectures and so on. So you're going to have 10 different versions of your program to compile versus just one. And the reason this works is because now the only thing that has to understand the computer's underlying architecture is the common language runtime. And so we ship this. This is our program. We ship the intermediate language. That's what we give to the user. And the user is going to have the correct runtime installed on their machine. And this runtime will be responsible for converting this intermediate language to the machine to actually execute the program. So it creates this decoupling between our program and the machine instructions. So that was the original advantage of this creating these runtimes. So this is the .NET runtime, or the common language runtime is another name they call it. But this idea was also implemented for the Java programming language. So to run a program written in Java, you need the Java runtime environment installed on your machine. And so, and the same thing happens. You have your Java source code. It goes to the Java compiler, and it produces what they call Java bytecode. This is the equivalent to the common intermediate language in .NET. This Java bytecode. And then Java virtual machine, which is another name for the Java runtime environment, and it's the equivalent of the .NET runtime, is what gets installed on the user's machine, and then that performs a communication with the operating system and the computer's architecture. Okay, one last slide about runtimes versus no runtimes. So if you're working with a programming language that has a runtime, the main advantage is that it makes cross-platform development easier. So Java's famous slogan when it was first created was write once, run anywhere. You write one Java program, and you compile that down to Java bytecode, and that's what that's the program, that's the format your program takes when you deliver it or deploy it to a user. And the user just needs the Java runtime environment, and it will handle the rest. Okay, so that's the main advantage. And then kind of another advantage that appears there is that you can also compile different languages to the same intermediate language. So we talked about C# and F# and Visual Basic, but that's also the case in Java. So there's a new programming language that I think Google made it maybe for Android, but it compiles down to the same Java bytecode that Java compiles down to. So that's Kotlin here. So Java wasn't good enough as is, and they created a brand new programming language that compiles down to the same intermediate code. So that way, you didn't need to install something new on all the devices that already have the Java runtime environment installed. Okay, and one last kind of truth about this is when you have a runtime, your programs tend to be slower because the runtime takes in instructions that are written in the intermediate language and then translates them on the fly into the binary that gets executed on the machine. So there's this translation step that happens in real time on the fly as your program is getting executed. So for that reason, your programs tend to be slower. Plus, the runtime can provide some other programming features such as garbage collection and that feature, for example, will make your program slower. Okay, so with no runtime, uh, all the code, it goes from the language that's written in C or C++ directly to binary by the compiler, and the compiler has to specifically know the target computer architecture that the instruction will be ran on, and it makes cross-platform development harder, right? And although it's not impossible, because if you just generate your program using every combination of computer architecture and operating system, well, then you'll have a version of your software that can be ran on any platform, in theory, right? So it's not impossible, but it's harder. And then the main advantage is that programs are much faster, because all that's left, everything is stripped away except the binary, and the computer hardware will read that binary directly, and there's no intermediate translation. So there's kind of the pros and cons of a runtime versus no runtime, and it kind of summarizes why we have that technical requirement of the user needs to have the .NET runtime installed on their machine in order to run our program. That is our technical requirement for our course. Okay. Okay, so the next group of requirements we're going to talk about are delivery requirements, and we won't need to go in as much detail about these as we did with the technical requirements. I just kind of want to give an idea of what these might look like. So, for example, a delivery requirement might be if you're making an iPhone app or an iOS app, it is probably going to be the case that you want to deliver or deploy your app to users through the Apple App Store, because your users will be more likely to download it and install it if it came through the Apple App Store. It gives them assurance that your app is not malicious, and so on. So that is kind of a delivery requirement for deploying an iOS app. In the C# world, say you're writing a C# class library, okay, and the best way, probably the best way for that library to reach users, so the users would be other programmers in this case, is if you package that library as a NuGet package, as we saw in a previous lesson. So again, it's not necessarily a strict requirement, but it's kind of a best practice, and is the best way for your software to reach others in that environment. Some other delivery requirements might be digitally signing your software. So if you ever downloaded some software and it's your operating system says, "Are you sure you want to install this? It's published by," and then it'll say Microsoft, or it's published by some other company, or maybe it'll say unknown publisher. And that kind of certification, putting that kind of certification on software, say, hey, this is published by Microsoft, that's how we know it's legitimate software. That could be a requirement, a delivery requirement of your software. So we'll call that digitally signing your software. Okay. In the Windows world, typically it's easiest for someone to install a Windows application using an MSI file. So typically it's nice to package your software in that way. But for a console app, for example, which we'll deploy because that's what we've been working with, a good way to deploy that to users is through an executable file, .exe file. Okay, so those are some delivery requirements. Okay, so this last set of requirements are business or organizational requirements, and you'll notice by this point in our requirements discussion, none of these requirements are strictly mandatory or necessary in the technical sense, but rather these are requirements that an organization or a software development team may have came up with because they're just a good idea. They're a best practice. Okay, so an example of an organizational requirement might be that all unit tests and all functional tests should pass before a new software version is deployed, right? So if we're iteratively developing our software through the DevOps lifecycle, our first version is something, and then we code some more changes, and then we have a new version of our software. Before we deploy that new version, all tests must pass, right? Again, not a strict requirement. You don't even have to have any unit tests in the technical sense, but a team might decide that that's a good idea, and that's a requirement for our deploying our software. Okay, an even more straightforward example is a manager needs to approve the software deployment before the deployment occurs, right? So if you're Microsoft, right, you have a lot of different developers that work on a new version of a piece of software, and simply we have a requirement that says, okay, well, once the version is complete or is considered ready by the development team, a manager has to look at it and approve and say this software is good to go, right? So that's another example. An electric company might say, even if the software is good to go, it's approved, we want the new version out there. They might say, well, we want the new version out there, but we cannot deploy the software if there is a major storm going on at that point, right? Okay, so another requirement that a organization of a specific type might deem a good idea. Another example is a cloud computing provider that says, well, we have to deploy our software, new versions of our software incrementally so that part of the data center can use the old version, and then we incrementally add the new version to one machine at a time so that we can continually provide service to our users. Okay, you get the idea. And just because I'm having fun with it, say you're working on a major software project that is going to be deployed on government property. On the extreme end, they might say, well, in order for the deployment to occur, Congress needs to pass a bill, right? So just another example, somewhat extreme example for what this could look like. And what that brings us to, all these different types of requirements, is the idea of automating our deployment process. And there are a lot of tools for this, but the one we'll talk about here is Azure Pipelines, right? And regardless of the tool, they all try to accomplish the same thing. And that is, regardless of the complexity of the deployment requirements, whether they're technical requirements or delivery requirements or organization requirements, regardless of the complexity of all of that, we should be able to automate our deployment process using some tool. Okay, so what that might look like in an Azure pipeline is that you have these series of steps, and the first step might be pulling the source code from a Git repository and compiling it to an intermediate language, right? If you're working in C#. Okay. And then the next step might be packaging the software into a particular format, maybe digitally signing the software, and so on. And then maybe automatically running all the unit tests and all the functional tests and verifying that all of them pass, right? And whatever else. All these technical steps of pulling the code, compiling it, running the unit tests, that should all happen automatically by the pipeline, and the pipeline should tell you if there's anything that's holding us back at that point, like, oh, there's a unit test failing, our software's not ready to be deployed. Okay, right? So that's the idea there. So technical steps, but then also procedural steps on that. So if you're deploying the Apple app or an iPhone app, contacting the Apple App Store, right? That might be a procedure your pipeline needs to follow in order to automate the deployment process. Sending, if you need a manager approval to deploy your software, that might look like the pipeline sends an email to a manager to approve or deny the deployment of the application. And then on the extreme end, it might be the Azure pipeline drafting a bill for Congress to vote on whether the software can be deployed or not, right? So whatever it is, the goal or what Azure Pipelines tries to argue for is that it should all be contained and automated within an Azure pipeline. And if there's human factors such as approvals or denials, the initiation of that process should be initiated by the pipeline. Okay, so that's the idea. And then the kind of deployment automation to its max is called continuous integration. And so with continuous integration, we say that as soon as source code is changed, so for example, if you do a git commit and then you push that commit to Azure DevOps, as soon as that happens, the deployment process kicks off and the new version of the software is built and created and released and deployed to users, and it happens automatically as soon as the code changes, right? And of course, this is not always appropriate, and there's some other nuances that we'll talk about in 2 lessons from now when we'll talk more about Git version control and the branching system. But that's the idea of continuous integration, is as soon as you change the source code, new versions of the software are pushed out and released to users. Okay. So with that, we'll get to a demo. I'm going to show an Azure pipeline here. Okay, so the original plan was I was going to build a Azure pipeline to deploy one of the apps we were working on this semester, but unfortunately it seems that there's a special request that you have to file in order to use a pipeline in the free version of Azure DevOps, and I didn't file that on time. So what we're instead going to do is I'm going to show this old pipeline that I have sitting around from some training I did several years ago. I think this might be, April 20th, 2021. And we're going to look at this pipeline, which automates the deployment of something. I don't quite remember what anymore. But let's look at the pipeline steps. So the first step in the pipeline is to get the code from a Git repository, right? No, shouldn't be any surprises there. We want to get our source code, and from there we want to build that source code, which technically speaking will be compiling it to that intermediate language. Okay. And then that's we can do more than that, though, right? The idea is we should be able to automate whatever the deployment is. We should be able to configure the automation here in Azure Pipelines. So here we're using an analysis tool called SonarQube, which is a code quality tool. So it looks at your code and might suggest that this is a bad variable name, or this doesn't follow convention, or this function should be broken up into multiple functions. So it's just this automated tool that makes suggestions on your coding practices. Okay. Here's some other stuff. We won't talk about Docker here. And from there, so this is a web app. So we need to, in our deployment, we need to copy our program to a particular web server in order to, that is the deployment process for a web app, is moving those files into a web server somewhere and letting the web server execute that program. Okay. And then there's one last step here, which is using this tool called White Source Bolt, which I believe looks at the third-party libraries that your app might be using. So CSV helper or fluent assertions or any of the other third-party libraries we talked about. It looks at those and determines if there is a security vulnerability in any of those libraries, and kind of suggests, well, there's a security vulnerability here, so maybe you should remove the dependency your app has on this third-party library. So it's a security tool that kind of helps you reason about these third-party libraries and any security vulnerabilities they might expose. Okay, so this is the definition of the build. Let's instead look at an old execution of this deployment. Okay, yeah, here we go. So all the steps I showed, here is what they look like after they've been executed. So here you can see it's getting code from Git in this first step. This is the feedback that Git is providing. Here, this is setting up that SonarQube tool. Here we're installing dependencies that we might have. So in particular, I think this is installing the .NET Core Runtime, as well as some other components that are required in order to host our software. Okay. If we look down here in the run code analysis, we can see the result of the SonarQube scanning. Actually, I think the results are stored somewhere else, but here it gives us some feedback about, maybe more about the report. Maybe it's over here. Okay, yeah, it's not here anymore. Okay, but anyway, it gives us some feedback about that analysis. Here's that white source bolt. So this is looking at, so here you can see all of the third-party libraries it's identifying. So what do we got here? Okay, I found the results to the white source bolt tool. Apparently, it was just added in a tab in Pipelines. It's like a custom extension that you can add to your Azure DevOps project. But anyway, here's the feedback here, and according to this tool, that it's got a high number of security vulnerabilities, and again, these security vulnerabilities are coming from using third-party libraries that are have some security issue with them. And maybe we can so here's the Microsoft ASP.NET Core MVC API Explorer version 1.0.302.217.dll. So this is a third-party library, and it's saying a denial of service vulnerability exists within this version of the library. Please upgrade the library to a newer version or something like that. What else we got here? We got a security. Yeah, okay. So we're using this library. It says a security feature bypass vulnerability exists in ASP.NET when the number of incorrect login attempts is not validated. So there you go. So not only is it telling us that, hey, we have this third-party library that has an issue, it's telling us what the security vulnerability that was identified with that library is. So this is that tool. An elevation of privilege vulnerability exists in the ASP.NET Core, fails to properly sanitize web credit. Yeah, so a lot of stuff here. Okay. Okay, so now we'll get to the last item here, which is talking about deploying our software using the Visual Studio Publish tool. So this is what you'll need to do on the Homework 5 assignment. I was going to have you build a DevOps pipeline, but because of the free tier issue thing, we're just going to do it this way. So We have our app in Visual Studio, and we want to deploy it to a user. And because this is a console app, so let's go ahead and run it real quick. Because this is a console app, we want to deploy it as an executable, or at least that's what we want to do if our user is using Windows. So to do that, we can right-click on the project here, right-click on this, and click Publish. And this opens our Publish tool. And there's a lot of places you could publish it to. So you could publish it to the cloud. You could publish it to all kinds of places. But we're going to keep it simple and just publish to a local folder or file share. Okay, so next. And folder. And I'm going to browse, and I created this folder here. It's called My Deployment Zone. Okay, so we'll click that, and let's click Finish, and close, and let's just let's look at this folder. So I have the data set in here, right? This is our data processing app. So I have the data set in here. But let's just publish this and see what it looks like. Okay, so not too bad. We have this executable file, but we also have this DLL file. And to execute the executable, we can open a terminal. And we should just be able to go lesson 10 exercise.exe. And okay, so they executed our program, and the program is expecting the path to the data file. Now, because the data file is in the same folder, we can just do, what's this thing called? EIA 923? EIA 9, yeah, okay. And there you go. This is our program executing. Now, the thing is, we have more than just this executable file. We also have this DLL, right? This DLL storing our C# code in an intermediate language. And we also have this CSV helper DLL. And if we were to delete one of these DLLs, let's delete CSV helper, for example. Oh, hold on. So let's delete this DLL. Right, now it doesn't work because now it's missing that dependency. So what we can do is we can create a standalone executable that has everything that this application needs embedded within it. So to do that, we have to change our settings here. And you'll see there's two deployment modes, framework dependent and self-contained. We can do the self-contained, and you'll notice that this requires us to know the architecture of the computer that it's being deployed to, not the architecture and the operating system. So in particular, on my machine, I have the Windows operating system, and it's a 64-bit computer architecture. So here we have to select that in order to create this self-contained deployment. And there's also a publish option here, if you expand this, to produce a single file. So we can save this now. And I'm going to go to the deployment zone over here. I'm going to delete all this here, everything except the data file. And now we're going to do the publish again. Okay, and now you'll see the only thing we have left here is this executable file and this PDB file. The PDB file is used for debugging purposes. Should we need to debug this executable, we'll need this PDB file to be able to do that. But I'm going to just delete it just to illustrate that everything we need is now packaged in this executable. And now we should be able to, yeah, and it still runs and everything. So now the only thing we have to deploy or give to our user is this executable. And of course, there's a lot of mechanisms you could use to do that. I mean, you could have this executable able to be downloaded from a website, maybe. You could have this executable maybe emailed to people or put somewhere on a shared file system to be downloaded from there, or there's tools that will allow you to, if the user you're deploying to is on the same computer network as you, you can just there's tools that can just kind of make this software appear there or automatically install this executable there. So this is our deliverable. This is what we give to the user, and then they can use our app. So this is a simple example here, and perhaps depending on our elective topics, we can touch on the deployment process in some other application domains, such as for web APIs or Windows desktop applications and so on. Okay.